the children's the continued part of real numbers. Today we will discuss one of the fundamental theorem of arithmetic or theorem 8.2. So now let us start theorem 8.2 or the fundamental theorem of arithmetic. Once again, theorem 8.2 or the fundamental theorem of arithmetic. So, what is the fundamental theorem of arithmetic? Every composite number can be expressed as the product of primes, and this factorization is unique apart from the order in which the prime factors occur. Once again, every composite number can be expressed. Every composite number can be expressed in terms of as the product of primes, and this factorization is unique. So apart from the order in which the prime factors occur. So once again, every composite number can be expressed as the product of primes, and this factorization is unique apart from the order in which the prime factor occurs. ಪ್ರತಿಯೊಂದು ಸಂಯುಕ್ತ ಸಂಖ್ಯೆಗಳನ್ನು ಅದರ ಅವಿಭಾಜ್ಯ ಅಪವರ್ತನಗಳನ್ನಾಗಿ ಮಾಡೋದು. ನೆಕ್ಸ್ಟ್ ಇವು ಆ ಅವಿಭಾಜ್ಯ ಅಪವರ್ತನಗಳನ್ನು ಘಟಿಸುವ ಕ್ರಮವನ್ನು ಹೊರತುಪಡಿಸಿ ಏನಾಗಿರ್ತವೆ, ಅನನ್ಯವಾಗಿರ್ತವೆ. ಸೊ ಎವರಿ ಕಾಂಪೋಸಿಟ್ ನಂಬರ್ ಕ್ಯಾನ್ ಬಿ ಎಕ್ಸ್ಪ್ರೆಸ್ಡ್ ಆಸ್ ದ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಪ್ರೈಮ್ಸ್, ಅಂಡ್ ದಿಸ್ ಫ್ಯಾಕ್ಟರೈಸೇಷನ್ ಇಸ್ ಯುನಿಕ್ apart from the order in which the prime factors occur. Next, the definition of Xcf and Lcm. So once again, the definition of Xcf and Lcm. So the definition of Xcf and Lcm. Xcf means highest common factor. Dear students, Xcf and Lcf as done in your earlier classes. So highest common factor or Xcf. So product of the smallest power. The product of the smallest power of each common prime factor in the numbers. in the numbers. Once again, so HCF means highest common factor. HCF means the product of the smallest power of each common 5 factor. Andre means ಸಾಮಾನ್ಯ ಅವಿಭಾಜ್ಯ ಅಪವರ್ತನಗಳು. ಕಾಮನ್ ಮೀನ್ಸ್ ಸಾಮಾನ್ಯ. ಸೊ ಪ್ರತಿಯೊಂದು ಸಾಮಾನ್ಯ ಅವಿಭಾಜ್ಯ ಅಪವರ್ತನಗಳು ಇರ್ತವೆ ಈ ನಂಬರ್ಸ್ ಅಲ್ಲಿ. ಸೊ ದ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ದ ಸ್ಮಾಲೆಸ್ಟ್ ಪವರ್ ಆಫ್ ಈಚ್ ಕಾಮನ್ ಫ್ಯಾಕ್ಟರ್ಸ್ ಇನ್ ದ ನಂಬರ್ಸ್. ನೆಕ್ಸ್ಟ್ LCF. LCF means least common factor. So the definition of LCF, the product of the highest power or greatest power, highest or greatest power of each 5 factor. Look at this. This one is HCF, each common 5 factor, but in LCF, each common factor, 5 factor, not each 5 factor, not common. So the product of the highest power or greatest power of each prime factor involved in the numbers. Once again, what is the definition of HCF and LCF? HCF is the product of the smallest power of each common 5 factor in the numbers, and LCF is the least common factor, the product of the highest or greatest power of each prime factor involved in the number. So this is the each common 5 factor, this one is only each prime factor. So next we take one more example. Next example, find the Xcf and Lcm of, once again, find the example 6. Example 6. Find the LCM and HCF of 6 and 20 by the prime factorization method. Find the 5 prime factorization. Method. Prime factorization method. So prime factorization method solution. Find the LCM and HCF of 6 and 20 by the prime factorization method. First we have find the LCM and HCF of 6 and 20. So 6 and 20. So 6 can be substituted by prime factorization method. So 6, 2 3s are 6. So 6 is equal to 2 into 3, means 2 the smallest power and 3 the smallest power. 2 3s are 6. Next we take 20 by prime factorization method. 20. So 2 1s are 0, 2 5s are. So 20 can be substitute in prime factorization into 5. This can be written as 2 to the power of 2 into 5. Therefore, the HCF of 6 comma 20 is equal to, so dear students, we take the smallest power. So the common smallest common prime factor is 2 to the power of 1 and 2 to the power of 2. So means the smallest power is 2 to the power 1. So common smallest power is what? So no one is there. So 2 to the power of 1 is equal to 2. So the HCF is what? The HCF is 2. And the HCF of LCM of and LCM of 6 comma 20. So LCM of 6 comma 2. So here HCF is smallest power of each common prime factor, but LCM of 6 comma 20 is the highest power of each prime factor. So this one is highest factor, 2 to the power of 1, 2 to the power of 2. The highest power is 2 to the power 2, and the remaining numbers 3 into 5. Once again, so HCF means smallest power in each common prime factor. 2 to the power of 1, 2 to the power of means 2 to the power of 1 is equal to 2. But in LCM, so the highest power, so 2 to the power of 1, 2 to the power of 2 is 2 to the power of 2. So highest power of each prime factor, and the remaining numbers is 3 into 5. So 2 2s are 4 into 3 into 5. So 4 3s are 12. So 12 5s are 16. So the HCF of 6 comma 20 is 2, and the LCM of 6 comma 20 is 16. Next, example 7. Find the LCM and HCF of 96 and 404 by the 5 factorization method. So next we take example 7. So example 7. Find the HCF of 96 and 404 by prime factorization method. Else find their LCM and find their LCM. So find the prime factorization of example 7. Find the HCF of 96 and 404 by prime factorization method and hence find their LCM. So solution. First, we apply prime factorization method of 96 and 404. So we apply prime factorization method of 96 and 404. First 96 and 404. So 96, 2 4s are 8, 2 8s are 16, 2 2s are 4, 2 4s are 8, 2 1s are 2, 2 2s are 4, 2 6s are 12, 2 3s are 6. So 96 can be written as 2 into 2 into 2 into 2 into 2 into 3. 1 2 3 4 5 into 3. This can be 2 to the power 5 into 3. So once again, 2 4s are 2 8s are 2 2s are 2 4s are 2 1s are 2 2s are 2 6s are 12, 2 3s are 6. So 96 can be written as 2 to the power of 5 into 3. Next we take 4 now. 4 can apply 2. 2 2s are 4, 0, 2 2s are 4. Again we apply 2. 2 1s are 2, 0, 2 1s are. So 4 not 4 is equal to 2 into 2 into 1 not 1. So this can be written as 2 to the power 2 into 1 not 1. So dear students, we find the Xcf of 96 and 404. So the Xcf of, therefore the Xcf of 96 and 404 is equal to, so what is Xcf? So Xcf means the smallest power of each. Once again, the smallest power of each, ಪ್ರತಿಯೊಂದರಲ್ಲೂ ಕೂಡ the smallest power of each common prime factor, that is 2 to the power of 2. 2 to the power of 2 is equal to 4. So 2 to the power of 2 is equal to 4. So hence find their LCM. So hence find their LCM. So for any positive integers a and b, so Xcf of a into b into LCM of a into b is equal to a into b. Dear students, every positive for any positive integers a and b is Xcf of a comma b into LCM of a comma b is equal to a into b. So Xcf of a comma b, okay, we will write Xcf of a comma b into LCM of a comma b is equal to a into b. So a comma b is for any positive integers a and b, and we also Xcf is 4. So LCM of a comma b is equal to a means 96 and b means 404, and so Xcf of 96 and 400 is 4. So 4 1s are 0, 4 1s are. So therefore LCM of, therefore LCM of A comma B means 96 and 404 is equal to 96 into 101. 96 into 101 means 96 into 101. 1 6 are 6, 1 9 are 9, 0, 0. 1 6 are 6, 1 9 are 9, 6, 9, 6, 9. So 9,696 means LCM is equal to LCM of 96 and 404. So, dear student, once again, the HCF of 96 and 404, 96 can be written as 2 to the power of 5 into 3, and also write 404 can also write 2 to the power of 2 into 101. So, the HCF of 96 and 404 is 4. Therefore, for any positive integer, HCF of A comma B into LCM of A comma B is equal to A into B. So, LCM of A comma B is equal, we find out the LCM. So, LCM is equal to A into B, 96 into 404. Though this HCF becomes 4. So, 4 ones are 0 ones are, therefore 96 into 101. Therefore, the LCM of 96 and 404 is equal to 9,696. So, next definition of next. For any two positive integers A comma B, we can write once again, for any two positive integers A comma B, we can write HCF of A comma B into LCM of A comma B is equal to. So, once again, for any two positive integers A comma B, we can write HCF of A comma B into LCM of A comma B is equal to A into B. So, next example 8. Next example 8. Example 8. Find the example 8. Find the HCF and LCM of 6, 72 and 120. 120 using the prime factorization method. 20 using the prime factorization method. So, solution we have once again example 8. Find the HCF and LCM of 6, 72 and 120 using the prime factorization method. Solution we have 72 and 120. Substitute in 5 factorization method. 6 will be factorized. 2 3s are 6 and 72. 2 3s are 6, 2 6 are 12, 2 1s are 2, 2 8s are 16, 2 9s are 18, 3 3s are 9. So first we take 6, 2 3s are 6. So 72, 2 into 2 into 2 into 3 into 3. So 2 to the power of 3 and 3 to the power of 2. So the last one is 120. So 120, substituting 1 factorization. 2 6 are 12, 0. 2 3s are 6, 0. 2 1s are 2, 2 5s are. So 3 5s are 15. So 120 we can write 2 into 2 into 2 into 3 into 5. We can also write 2 to the power 3 into 3 into 2 to the power of 3 into 3 into 5. So once again 6, 2 into 3, 72. 2 to the power of 3 into 3 to the power of 2 and 120. 2 to the power of 3 into 3 to the power 1, 5 to the power 1. Here, so the Hcf of 6, 72, 120 is equal to, here we can observe, can write 2 to the power 1 into 3 to the power 1. Here is the 2 to the power of 1, 2 to the power of 3 and 2 to the power of 3. Which one in this number, which one is the least power of the common factor? Yes, 2 to the power of 1. So 2 to the power of 1 and 3 to the power of 1, 3 to the power of 1, 3 to the power of 2. Which one is the smallest power? Yes, 3 to the power 1. So dear students, 2 to the power of 1 and 3 to the power of 1 is the lowest, means least powers of the common factors 2 and 3. Once again, 2 to the power of 1 and 3 to the power of 1 is the least powers of the common factors 2 and 3 respectively. Once again, 2 into 3 is equal to 6. So the Hcf of 6, 72 and 120 is equal to 6. Next one, Hcf of 6, 72 and 120 is equal to, so here is the highest product. Which one is the highest product? Yes, 2 to the power of 3, 2 to the power of 3, 2 to the power of 3, 2 to the power of 3 is the highest prime factor, and 3 to the power of 1, 3 to the power of 2 and 3 to the power of 1. Yes, 3 to the power of 2. The remaining number is 5. So here 2 to the power of 3 and 3 to the power of 2 and 5 is the highest powers of the prime factors 2, 3 and 5 respectively involved in the numbers. So these are all the highest powers of the 5 factors 2, 3, 5 respectively as involved in the numbers 2 to the power of 4, 4 to the power of 8, 3 3s are 9, 5, 9 8s are 72 into 5, 5 2s are 10, 7 5s are 35 are 36. So once again the HCF of 672 126 and the LCM of 672 120 is equal to 8 into 9 into 5, 9 8s are 72 into 5, 5 2s are 10, 1, 7 5s are 35 plus 1 36. So find the HCF and LCM of 672 and 120 using the 5 factorization method. So the HCF of 672 126 and the LCM of 672 120 is 360. Next class we will continue the exercise 8.2. Thank you.